Today we discuss example of matrices. Example of matrices. Now we start about from discrete metric. Discrete metric denoted by dxy equal to 1 if x not equal to y and 0 if x equal to y. Then we prove it. We know dxy greater than equal to 0 from seeing this for all xy belongs to x, and dxy equal to 0 implies by x equal to y. Okay, and dxy equal to dyx and dxy, if dxy equal to 1, then dxz less than equal to dxy plus dyz. Possible when? Because this implies x not equal to y. Here x dxz, two possibilities 0 and 1. If 0 then x equal to z, if not 1 then x not equal to 1. That means if 1 then here also 1, and here this one z. Okay, then this one if x not equal to y, or here 1 0 or here 1 0. If here 0 then here all possibilities comes. That means if this one equal to 0 then this one equal to 0 possible, 1 possible, here 0 1 all possible. That means 4 possibilities here. If this one equal to 1 then this one just 1 0 or 0 1. These two possibilities come, or 1 1 come. 3 possibilities come. That means if this one equal to 1 then 3 possibilities come here. If this one equal to 0 then 4 possibilities come here. In this way we proved all properties of matrix. That means matrix satisfies all properties. So dxy be a metric which is called discrete metric, and xt be a discrete metric space. Okay, now we're going to further another more typical example of metric which can't handle easily, and is also important for us. We'll see this example in various examination and various good book exercises also. So we prove this one metric. Now we prove it. We just write it delta xy equal to dxy by 1 plus dxy. Okay, this one we prove it. This one be a metric. Then if dxy one metric, if dxy metric, then delta xy metric we have to prove it. Okay, now we write just simple one. Dxy greater than equal to 0 implies that delta xy greater than equal to 0 for all xy belongs to x. Dxy equal to 0 implies by x equal to y. Similarly, delta xy equal to 0 implies by x equal to y. Now dxy equal to dyx, if this one happen, this implies that delta xy equal to delta yx. If dxz less than equal to dx y plus dyz hold. Then we have to prove that, to prove delta xz less than equal to delta xy plus delta yz. How we prove it? We take ft equal to t by 1 plus t. This implies that f dash t equal to 1 by t whole square. Here 1 plus t minus t, that means 1 by 1 plus t whole square greater than 0. So f is an increasing function. F is an increasing function. So what happened? Happened now. Just erase our simple portion. Erase simple portion. Just f of d of xz less than equal to f of d of xy plus d of yz. This implies that delta xz less than equal to d of xy plus d of yz by 1 plus d of xy plus d of yz. Okay, this again we erase this portions also, since f is increasing function, so this one is done. We erase this now. Now we get this less than equal to dxy by 1 plus dxy plus dxyz. Here also we write dyz by 1 plus dxy plus dyz. This less than equal to dxy by 1 plus dxy. Here we write dyz by 1 plus dyz. Because this one is greater than 0, dxy greater than equal to 0, and here dyz greater than equal to 0. So 1 plus dxy dyz greater than equal to 1 plus dxy. So above this one is hold. Okay, now we erase this above portions also. These portions we erase, and we get what we get. We get the triangle inequality hold for this delta. So delta be an metric also. Now we write it properly. So delta xz equal to delta xy plus delta yz for all x, y, z belongs to x. Okay, understand? I think this one is trivially hold. So delta be a metric and x delta be a metric space. Now we erase this portion properly. Next we discuss another familiar metric, which one is satisfies all the properties of metric, and we prove it now. This one is also important for exercise, very important exercise, and also important for examination purpose and other purpose also. That means if you handle with metric, if you culture with metric, if you interested on metric, then these portions, this familiar example are obviously needed for all. So we start about this. We define same thing, delta xy equal to minimum of 1 txy. Okay, then this one we have to prove that this one be a metric. What way to prove it? We know that dxy greater than equal to 0. This implies that delta xy greater than equal to 0. And also we know that dxy equal to 0 implies by x equal to y. So what we happen, del xy equal to 0 implies by x equal to y. Okay, now this two portion is complete. Now third portion, we have to prove that del xz, to prove del xz less than equal to del xy plus del yz. Now we check it. Del xz equal to minimum of 1 dxy dxz. That means either 1 or dxz. If del xz equal to 4, then dxz less than equal to 1. Okay, and so for all xz belongs to x. Now then we see that del xy less than equal to 1 and del xyz less than equal to 1, and also this triangle one equality hold. Also dxy less than equal to this one, dxz less than equal to xy plus dyz hold. Okay, if this one equal to 1, then this one less than equal to, and simply d be a metric, or then d satisfies triangle inequality. So delta xz less than equal to delta xy plus delta yz. Okay, both are less than equal to, and obviously this one also less than equal to. Next, if this one, erase this portion, if this one equal to dxz, if this one equal to dxz, then simply if this one equal to dxz, then we get dxz greater than equal to 1, and obviously dxz greater than equal to 1, this implies dxy plus dyz greater than equal to 1. Here for all xz belongs to x. So this implies that dxy greater than equal to 1 and dyz greater than equal to 1 also. Okay, so here we write again in this way. This is beta dxz greater than equal to 1. So triangle inequality follows. So delta vn metric and delta va metric space. So we write it now, delta va metric and x delta va metric space. So we handle three important examples. Now x delta va metric space and delta va metric. So today stop now.